Hi, welcome to an introductory video that'll explain a little bit about what's going on with the newest release of the jTIPS well log modeler. The current release is version 3.1, and one of the big things you'll notice right away is we're now presented by HSB Geophysical, uh, which includes all of the former products provided and supported by Petroseismic software. So, when we pull up the jTIPS well log modeler, I've loaded a sample project. You've used it from before. This is what a sample well may look like. So what's new? What's some of the new things? I'm going to jump real quick to looking at the 1D synthetics. We've always had this, but we've done a few things to make it a little more palatable for you. So if I go to synthetics and hit 1D models, you'll see our well logs, and we can control that layout, and we'll see a 1D synthetic, the near trace based on this, the well log data. And we can see our hydrocarbon zones. And we've applied a simple Ricker 40 Hertz wavelet over here. And again, just as a reminder, if we want to change the wavelet, for this model, we simply click on the wavelet. It pops up. We have some options that I'll touch on in a bit. But then here's the wavelet. And this is our familiar wavelet menu. So I could change the frequency to 55 Hertz. I could change the sample rate to 2 mils and accept it. And now this synthetic changes. Now the one thing that not everybody seems to know about is we can add more models. We can add as many as we like and view these side by side. The way we do that is very simply we go to Tools, Add Model. And what it's going to do, it's going to take all the properties that are used to generate this one, the wavelet, whether I'm considering internal multiples or not, and it will just copy it, and right now I'll hit accept, and it's going to add one next to it. So right now these are the same exact models. I've taken this well log and applying the same wavelet, and I'm looking at primaries only, which is what we would normally look at in a synthetic. So one of the things that we can test with this is what's the impact of the frequency. So right over here we had a 55 Hertz. I'm going to go back to the original model, and I'm going to change that to a 35 Hertz wavelet and accept that. So you can see now it says Ricker 35 Hertz. And I'm going to change this to 40 Hertz. Accept. Now what I'm going to do, so now I have one at 35 and 40. And you see there's not much difference. You can probably guess where I'm going with this. So I'm going to add another model next to it. So it's going to take this model, which is sitting at 40 Hertz, and I'll add one at 45 Hertz. And then I'll add another one at 50 Hertz. Obviously you can tell what I'm doing here. And we'll add another one at 55 Hertz. This is, I'm sure, very exciting to watch on a video. But what we're going to be able to do is to see what changes that an increased frequency may have. And we can start to see some extra events included occurring in here. So that's the type of thing we can do. And we can also change the order of these. So this is new. So if we want to move this model, we click it and it's now moved to here, my 55 Hertz. If I don't want this model anymore, I click on the wavelet option button. There's a button that says delete. So I'm going to delete it. Are you sure you want to delete it? Yep, I'll delete it because they're so easy to create. So I'm going to delete a few more of these. And you can see how easy it is to create and compare a whole bunch of these models side by side. One of the other things I like to do is when you have this particular model, you can click on it. I'm going to go Tools, Add a Model, and again, it's going to take this model and just copy it. So now they're exactly the same primaries. I want to consider what would the synthetic look like if I'm considering internal multiples on here. So I simply click on the header again for this model, and I said compute internal multiples, and I click that, and yep, so now I'm looking at internal. This is primaries and multiples. This is just primaries. So I can start to look to see the difference that the presence of multiples may have on here. So this is one of the quick things that we can do with the new version of software. And again, a bit of an enhancement of what we've always been able to do previously. One of the major things that we can do, that we've added now, is seismic. You see the new button across the top. It's called seismic. And what we're going to do is allow you to import a 2D seismic line, view that seismic data, and then tie this well synthetic to it. So I'm going to hit open seismic. In this case, I've already picked a seismic, a SegY file that we pulled in, and we see this model right here, and I can scroll and move things around. The controls up here for the seismic, I can control the spacing, how many traces per inch I want, and the trace gain. And then we're going to plop the well in here. This is the synthetic from this well that dropped in. We've put it in at about trace 455. Now I'm not too worried in this example about the actual tie of the well. This is really just kind of showing you how what exists here. And I can take this well location and I can move it many different ways. I can just, on this well controls button, I can click on it and hold it down and move it left or right where I know where it is. If I need to apply a time shift to line up some known events, then I have a button right here that just shifts the synthetic trace up and down. I'm not doing anything to the SegY data at this point. And then I have obviously the trace gain that we can control for both the synthetic as well as the seismic. We can also take this synthetic, and I have a button up here for compute internal multiples. So just like we showed on the other, I can turn that on and off, and so I can look to see if considering the multiples actually gives it a better well tie. Now we can get it to stretch and squeeze, but I suggest that you go look at the documentation to do that. But we can take this and stretch and squeeze in certain areas to fine-tune our well tie. One of the other last tools that we've added in here that I like is we go to Tools, Extract Wavelet. And what we're going to do when I click on that, it says we're going to give it a window, a top time, a bottom time, and the trace index. Right now it's just at one trace. I'm going to go from 290 to 350 just to show it, and the max number of frequencies. All this we can change. All right, so what we have now is a window. Okay, this is our window, and we're swiping it over the seismic data. And what we're looking over here is the spectrum. So I can look at what the content is of this as I move this up and down. So you'll be able to see what the frequency domain would look like. And this is our autocorrelation function that's being applied. I can make this, if I want, I can squeeze this window so it's just looking at one trace. So maybe I just want to go to that one trace that's over by the synthetic. So I can just look at that. I can also click on it and type in the values if I want. So now that I have this synthetic, all right, I know what my spectrum looks like here. I've got an autocorrelation length of 120 milliseconds. I can truncate this, and I can have a trapezoidal, triangular Hamming function that's trimming this. So this is great. So we've got our frequency spectrum right here that we can look at. But what we'd like to do is create a wavelet from that data that we can do. So we want to extract it. So the easiest way to do it is you notice when you put your mouse over this curve, it'll highlight, and I click on it. And we've always had one of the wavelet types is specified, where you're specifying the frequency and amplitude pair. We've tried to make this easy here. So now the red line that you see here corresponds to the frequency spectrum as extracted from the seismic data. So rather than try to figure out something that can match it, we can actually just add points in here. So I'm going to take this point and slide it over. I'll take this point, slide it down. I'll take that point there. You're like, great, that's not enough points. Awesome. Come over here, we hit add points, and we just kind of start digitizing where we want points on here. And now we're going to have a specified set of frequencies and amplitudes that really kind of matches this. And you can spend as much time as you want to do that. And it creates this wavelet that applies to that. We do this at 0 phase. And then you'll notice I've got my synthetic, 1D synthetic over here. When I hit accept here, it's going to take the function that the wavelet that was on there and apply this new extracted wavelet. And I can save the wavelet and restore it for later use. And when I want to get rid of this, if I don't want to view this, one of the great things to do is you can hide the extraction region. So it hides that. And now I have this, and I can take a nice screenshot of it and let people know how I got this wavelet, or if I'm done with that, I can close that all together. So that's just a real quick overview of what's new in version 3.1. Please go through the documentation. We'll be producing more and more videos and content to help explain this. I think when you get into working with the weld tie and stretching and squeezing, you're really going to be happy with the product.